Welcome back, folks. In today's class, I'll continue with the topic of force. And in the last class, we discussed uh, what force is, and then we also talked about that how we can calculate the force acting on an object which is placed on a horizontal plane. So I'm going to give a recap, and then we're going to move forward. So if this is an object placed on a horizontal plane, and then I try to push it in the forward direction, so this becomes the force applied in the forward direction. Because of the frictional force, the the frictional force will try to resist it in the opposite direction. This becomes the force of friction. And then if I have to write the equation, I can write the equation as F net is equal to force applied. I should write it as force applied and plus minus force of friction. Again, depending upon which direction force applied is, opposite to that will be the force of friction. Another equation we end up writing if the object is moving in the vertical direction. Let's say the force applied is in the upward direction. So this is force applied, and then gravity will act in the downward direction. This becomes Fg, and then I can write the F net equation, F net equal to force applied, and this will be minus Fg. Fg will always be downward, so that's why I've taken this as negative. And in this case, we will not consider G value as negative 9.81 because we've already considered the sign down here. So we will only take the value as 9.81 in this case. Again, if you are a little confused, you can go back and watch my previous lectures. You'll be able to get to know why we will consider the G value as 9.81. So this was we talked about when the object is placed on an horizontal plane. And then we also talked about that if the object is placed on a horizontal plane, and then there is force of coefficient of friction given to you, or you're asked to find the coefficient of friction, then you will use the force of friction formula as mu mg. That's what we said. So these are certain concepts which we need to keep in mind when we are trying to solve the objects placed on a horizontal plane. One last concept, that if the object is not moving, then the net force will be equal to 0. Now in today's class, we'll talk about when the object is placed on an inclined plane. So if this is an inclined plane and this inclination is angle theta, and the object is placed on this inclined plane, I wanted to find out what different forces are acting on this object. So I'm going to give you first of all a shortcut, and then we will talk about in detail also from where we got the equation. So the equation to find the forces acting on this inclined plane is force net is equal to force applied in plus minus force of friction and minus mg sine theta. All right, and then we will write this force of friction. Force of friction can be mu g cos theta, depending upon if the coefficient of friction given to you, you will use this formula. If the coefficient of friction is not given to you or not been asked to find out, then I will use direct value of the force of friction in the given question. Now, how we end up getting to this equation, that's what we will try and learn. But this is the basic equation which is used to solve any problem when the object is placed on an inclined plane. Now, let's redraw the object placed on an inclined plane. And in this case, the object, as I said, is placed on an inclined plane at an angle theta. So what I'm going to do is I'll try to draw the free body diagram for this one. So gravity always acts in the downward direction. So I'll show the gravity straight downwards. This will be mg. Fg equal to mg. Now, normal force means Fn. Fn always acts perpendicular to the plane, to plane. So plane is which one? Plane is inclined plane. This is an inclined plane at an angle theta. So normal to this one will be like this. So in this case, this becomes Fn. Now I wanted to find out the Fn value. In previous cases, if I show the diagram, in previous cases, because of Newton's third law, we said that whatever the value of Fg was, same value was for Fn, because every action has equal and opposite reaction in the opposite direction at 90-degree angle to this plane, there was normal force. Now, normal force is acting 90 degrees to the plane, but it is not acting at 90 degrees to the force of gravity. Force of gravity is acting straight downwards. So I have to take the uh, components of this force. So this angle down here will be equal to theta. So this is the geometrical concept. I'm not going to get into the detail of this one, but whatever this angle will be down here, that same angle will be up here too. So now this is, if I try and draw the right angle triangle here, this becomes FG. So if this is angle theta, this will become FG cos of theta. So which I can write it as mg cos of theta. And this one will become mg sine of theta. Now I'm going to use the vector concepts. So this vector, and let me change the color. So this vector down here is trying to push the object in the downward direction, the blue one I'm talking about. So blue one, I can replace it down here also, or up here, shall I say, because of the collinear property of the vector. So if a vector is represented like this, I can represent it on the plane anywhere else as long as I'm keeping the direction same to the previous vector. So I've changed the vector's position from here to up here. Now, uh, other forces, this Fn, which will be equal to opposite of mg cos theta, and then force of friction will be equal to mu mg cos theta, and that's what we said. Force of friction was equal to mu mg, or we wrote it as force of friction equal to mu fg. That's what the force of friction was. That was on a horizontal plane. Now this is on an inclined plane, so being on the inclined plane, there is cosine theta which is added to this. So if the object is trying to move in the downward direction, force of friction will be in the opposite direction. And if we are applying a force in the upward direction, then the force of friction will be downward direction. So depending upon where you're applying the force, you can decide the direction of the force of friction. So for the time being, I'll represent the force of friction again in the downward direction, because I wanted to show the applied force also in this case. So applied force, let's say, is acting in the upward direction. This is the applied force. So this force of friction will be in the downward direction. And this blue vector, which I'm changing it to the white vector now, is equal to mg sine theta, which is the force acting due to gravity on an inclined plane. Now I can sum up all these three forces and find out the net force. So this is one of the force, this is another force, and then the third one is this force. So force applied minus force of friction, again because the object is moving downwards, that's why I've used the negative, and minus mg sine theta. And one more time, gravitational force always acts downwards, so mg sine theta, come what may, will always act downwards. Mg sine theta is trying to push the object towards the ground. It cannot act in the upward direction, so that will be wrong. So remember this thing, this will always be downward force. And then if I sum up all these forces, that will come out to be F net. So that's how we end up driving this equation. So if you are given the coefficient of friction, then this equation will again change into minus mu mg cos of theta minus mg sine of theta equal to F net. So hopefully you were able to understand how we end up driving the equation. So I'll see you in the next class with some more examples on this topic. Till then, goodbye.